Good morning, and thank you, commissioners, for having us on today. I'm Maya Hayden. I lead our coastal adaptation program at Point Blue Conservation Science, and I'll be providing a demonstration of the newly released our COSTAR Future web tool. For those of you unfamiliar with our COSTAR Future, or OCOF, it is a partnership led by Point Blue Conservation Science and USGS, and over the last decade has brought resources to understand, visualize, and adapt to sea level rise, coastal storms, and other coastal hazards. It's the primary platform for data visualization of the USGS Cosmos model. There are lots of new features and functions in the updated site, but today I'm just going to be focusing on the groundwater table rise component. So if we go to our costarfuture.org, you'll get to the landing page of the new platform, and it basically has four main components. There's a section about the tool and getting started and how to get help. There are case study examples of how the information and the viewer have been used for sea level rise adaptation planning. And there's the science and modeling page, which gives you information about sea level rise projections, the latest for California, more technical information about Cosmos, and what output products are available. And although I'll be focusing today just on the groundwater piece, I just wanted to remind people that we do have the shoreline change and cliff retreat data visualized in the viewer, as well as the surface flooding and derivative products. But the main component of the tool is the hazard map. And on the left-hand side of the viewer, you can choose the scenario topic to look at. So in this case, the flooding output product, and then choose whatever combination of sea level rise and storm frequency that you would like. And you can change these to feet if that is helpful. On the right side is the legend, and there are additional layers that you can add on here as well. So as an example, most people will come to the viewer to look at the flooding in a particular location. So for instance, we can increase the amount of sea level. We can look at that in combination with different storm scenarios and see how flooding in this particular location, and by that I mean surface flooding, might be affected. In addition, now you can look at the groundwater table. So if you select the topic groundwater, you will go to the groundwater data set that Kevin has produced for the whole state. So here you can see not only the marine inundation, so that's surface flooding, but then you can start to basically look at how deep is the water table in certain locations. So these colored regions basically show you the depth to the water table. So you're looking below the surface. The areas in red are places where you might start to see emergent water coming up out of the surface, the ground surface, and then the orange is very shallow groundwater. And so, you can increase the amount of sea level and start to see how not only that surface flooding component comes in, but also how the groundwater table will react as a result of sea level rise. In addition, as was mentioned, the modeling was run with 3 different assumptions of subsurface geology. So you can look at a more permeable condition, which leads to a deeper water table, a moderate, and a less permeable. And those 3 options are available for every sea level rise scenario. So we've also provided some guidance if you hit a question mark, some guidance on which option should I choose, depending on whether you have local knowledge about your local geology and or depth to the groundwater table, or if you're thinking more in terms of risk tolerance. For instance, if you have particularly critical assets that you're concerned about with potential groundwater impacts, then you might choose the less permeable option of the subsurface geology so that you get the shallowest water table for any given scenario. And with that, thank you very much for your time. We'll take any questions that you have right now, and also please feel free to reach out to us for further information.